Hello, I'm Jerry Winslet along with Mike Dial, and in this course we're going to talk about the heat pump water heater. Heat pump water heaters use the heat and humidity from room air to heat water stored in an insulated tank, making them much more efficient than standard electric water heaters. A fan pulls room air across an evaporator coil, transferring heat from the air into refrigerant in the coil. The heat turns the refrigerant into a vapor. A compressor compresses the vapor and pumps it through condenser coils that are wrapped around the tank. After transferring heat to the water in the tank, the refrigerant turns back into a liquid and the process repeats. Like standard electric water heaters, the heat pump has upper and lower heating elements that operate automatically when the room is too cold for the heat pump to work efficiently or when there's a larger than normal demand. Since heat pump water heaters produce condensation, a condensation drainage system is needed. In some cases, a condensation pump is used to remove condensate. All right, so let's talk about the heat pump water heater. We're going to talk a little bit about some of the top service items, but first let's talk about some codes you might see on your display here. The first one would be HPO.
So we are going to see some displays if we have any faults, but there are a couple of things that are going to be displayed that we really shouldn't worry about. HPO is one of those, and that's referring us back to our heat pump operating range.
Okay.
So a couple of things that we have to keep in mind. The heat pump is designed to work in an air atmosphere that is above 45 degrees and below 120 degrees. So if the air temperatures exceed that, right, either below 45 or above 120, we'll see the HPO displayed there. And what that means is it's not a safe range for the heat pump to work. We'll still have hot water because the electric elements, it's going to divert automatically to that mode. Something else that could cause that is if our average tank temperature is 49 degrees or below. So again, it's just saying that the water in the tank may be really cold. It's going to bring the electric elements on. Once that range gets into the correct range, it'll go ahead and resume heat pump.
Even though you see that we still have hot water down here because of the elements.
Yeah, anytime we see HPO on there, it's going to automatically switch to the elements to make sure that you still have hot water.
Okay, how about ICE?
So ICE or ICE, this means that the heater is going into a defrost operation cycle. So if we have a cool ambient air, we might be above 45, but somewhere between 45 and 50. And we also have a cool tank of water. What can happen is we can drop the refrigerant temperatures there to where we'll get a little bit of ice that will form on that coil. So the sensors will see that, and again, switch it over into the electric mode while that ice clears and get everything back up into the right range. Still have hot water.
Okay, how about the SF mode?
Now, SF is something that we need to take some steps. SF is an abbreviation for service filter. So the filter is on top of the water heater. Now, you can remove the filter, but the best practice is just use your vacuum and vacuum it off in place. That way we don't worry about getting any dirt inside of the water heater.
All right. One of the things that we talk about too with these heaters is, you know, we have call centers here, so we know what's going on in the field. And one of the top calls we get is, I don't have enough hot water with this. You know, most of the time, that's really not the heater, right? It's on the front end, right?
It's on the front end, so not enough hot water, especially if they're used to a standard electric water heater. We're going to have a little bit better recovery. Still not great, but it's a little bit better recovery. But sizing is so critical. So we probably need to go up in size a little bit from what you might be used to with an electric water heater. Make sure that in whatever peak period that we're going to use hot water, that we have enough water heated for that. And that way we'll have time for the recovery. And that's going to be the other side of this. Because in lieu of the lower element, where a traditional electric water heater would use that lower element, we're using the heat pump to put in. And it's about half of the heat input as a lower element. So it takes a little bit longer for it to heat up. So where you might be ready to go again in 2 hours, this one might take 2.5 or 3 hours because it's going to take a little bit longer.
People don't realize that whenever they get one of these, or they're not told in the beginning, or they don't do enough research. And this does take a little bit. If you're using a heat pump, it's going to take a little bit more for it to recover, a little bit more time.
That's correct.
Another question that they may ask us is, the heater's not as efficient as they thought it should be.
And that comes back to largely being installed.
Right.
So the first thing we want to make sure is that we've got it installed in the big enough space. So we need at least 700 cubic feet of space for air, and that's to allow us to have enough heat for this to actually operate.
Right.
So once we've verified that, we also want to make sure that we're taking advantage of all of that space. So we're pulling air into the top of the water heater, and we're discharging the air outside from the right side.
Right.
So where we've got it stuck in this corner is a really good application, because we're going to blow this air out and it's going to mix with all of the air in the room and then come back, and so we'll be able to take advantage of all that heat. But if we've got this installed where there's a wall right here, maybe the 6
Right.
inches of clearance,
Yeah.
what can happen is that cold air is going to come out, it'll hit that obstruction, and it'll just get pulled right back in, and we don't take advantage of all of that space.
And also, you could be outside of the temperature ranges as well.
Could also be outside of the temperature ranges, so if you're installed in an attic in the summertime where we're going to see those temperatures above 120 degrees, or if you live in a very cold climate and this is installed in your garage, you may have some periods where that temperature falls below the heat pump operating range, below that 45. So those are conditions that can cause this to not operate as efficiently, because it's going to rely more on the electric elements and less on the heat pump.
Okay, what about the heat pump? Are there any situations where we might have problems with the heat pump?
So we could have some problems with the heat pump, and the first thing that we want to check is make sure that the fan is coming on.
Right.
So you can hear the compressor come on, and it sounds kind of like an air compressor. The fan doesn't make much noise, but you'll be able to see it and you'll be able to feel the air. So if the fan's not coming on, it is powered by 240 volts that comes off the control board. It may just be a loose connection, or it could be a bad fan.
Okay.
But once we know the fan is coming on and the compressor is coming on,
Right.
we could have a problem with the sealed refrigeration system.
Okay.
And this is really much easier to diagnose than you might think. What we need is a sensible air thermometer, so something that's going to have a metal probe that's going to measure the air temperature.
Okay.
And we're going to measure the temperature going into the top of the heater, that air that's being pulled in. And then we're going to measure the discharge temperature.
Okay.
And we should see 8 to 10 degrees difference between those. So we should be cooling at 8 to 10 degrees. And if we see 8 to 10 degrees, then the heat pump is operating correctly.
Right.
And then we can look at some other things. If we don't, then there's a problem with the sealed refrigeration circuit, and give our folks at the technical support a call.
Okay, what about, I know you can put this in, you can use duct kits with this. Are there anything we need to keep in mind when we use a duct kit?
So duct kits can also limit our efficiency if they're not installed very well. So we are allowed to duct with our newer models up to 50 feet just with the duct kit.
Okay.
But once we go over 10 feet,
Is that 50 feet equivalent,
So it's-
inlet and outlet?
so that's inlet and outlet combined, so a
Okay.
combination of the two, not 50 for one, and so
Okay,
not a
alright.
total of 100.
Okay.
If we go over 10 total feet, what happens is there's a little more restriction, so we're moving a little less air through there, which affects how quickly we can get heat in there.
Okay.
So if you go over 10 feet, it's not required, but we'd be recommended, we've got a duct booster fan that would help to compensate for that extra restriction.
Okay, and can we discharge air into different spaces, or how are we using that?
So we really want to discharge air into the same place that we're pulling air from.
Okay.
And so one common application would be, we've put this in a closet, maybe on a retrofit where we had a water heater that was in the closet that didn't need air because it was an electric heater.
Okay.
So it will have a full louvered door that will allow the air to come in, and we might discharge out of the side. So we want to discharge that back out in the hallway, just somewhere where we can take advantage of more of the space that's in the room. If we discharge into a different space, what can happen is we can pull the space that the water heater is installed in into a negative, or we could put positive pressure on the other, and the fan's just not powerful to overcome that. So we'll reach a stalemate where we're actually not moving any air through the duct system. No air through the duct system means that we're not putting heat into the water.
All right. And now the last thing we want to talk about is, you might see on here, is an ECC. What are we talking about with that?
So ECC is probably one of our top service items as far as calls that we get. And what that means is that the compressor is not running when the heater thinks it should be. So we don't have to worry about HPO. Our ambient conditions are good. We've sent a call for heat. We've told the compressor to come on, and we don't see the compressor running.
Okay.
Now that could be an electrical problem, or it could be a sealed refrigeration problem. So the first thing we want to do is reset the water heater. So power it off, power it back on, wait for it to go through any diagnostics that it needs to do. And we want to make sure that the compressor does come on with the fan.
Okay.
If the compressor doesn't come on, it may be an electrical problem, a loose connection. We probably want to get somebody that's qualified to work on a heating and air unit out there to double check that. But if the compressor does come on, then again, we're going to check for that temperature drop between the inlet and the outlet. Look for that 8 to 10 degree temperature drop. As long as we see 8 to 10 degrees, the compressor's okay, but if we don't, that indicates a problem with the sealed refrigeration circuit, and give our folks at tech support a call so that they can determine whether we need to get somebody out there to look at it.
Okay, and to me, it sounds like a lot of the things, I mean, installation is very important, doing the right thing, having the right enough air, the right temperatures, is really gonna save you a lot whenever you're putting one of these in. Is there anything else we need to keep in mind whenever we're putting these in, as far as the installation?
The volume of space, being able to take advantage of all of that air in that space, that's probably the most important thing.
Right.
Beyond that, as far as service items, is we have expectation problems. So making sure that we understand that this is going to take a little bit longer because it's half of the input of a standard electric element, so it's going to take twice as long to heat up. So the periods in between when we can use hot water may be a little bit longer than with a traditional water heater.
And one more thing, with the tank, from here down, it works just like an electric water heater. Especially if one of the elements goes out, we're just going to be checking them and changing them out just like you would a standard electric water heater.
Just like a standard electric water heater, this will actually tell you that it doesn't see a connection through the either upper or lower elements. It'll give you that fault, which really tells you exactly where to look. And then when to power off, just like we would with standard electric, we can check for continuity or for ohms through that element, make sure that it's good, and pull it out and replace it just like you would a standard electric heater.
All right, so it all boils down to the installation and having the right size water heater for the application.
Sizing is the critical first step.
Exactly.
After that, it's making sure you have enough air.
Yep.
And that you're able to take advantage of all of that volume of air.
Yeah, and if you have any questions, go ahead and give technical support a call.